Hi there. Today we're going to talk about Lesson 70, and Lesson 70 has a lot to do with volume. And if you remember, not too many lessons ago, I talked about geometric solids, and geometric solids are very related to volume because typically once we start talking about geometric solids, we begin to talk about how we can fill those solids up. And when we're filling those up, we are essentially creating volume. And we need to know how to measure that volume. A good definition for volume is the space taken up or occupied by a shape. We use units to measure volume, and they are always cubics. It would be as though you made little tiny cubes and you filled up any shape with these little tiny cubes, and therefore they call them cubics. They're cubes. They can be tiny, and they can be larger depending on whether you're dealing with meter cubic units or nanometer cubic units, so they can be really tiny too. There are formulas that we use to find the volume in shapes. Polyhedron geometric shapes are found by using a basic formula, and polyhedrons have a length, a width, and a height. And so if we had a shape that looked like this, okay, this is the base of the shape here, okay, and we have the length, which is 6 units, the U just mean units, the width, okay, from here to here is 2 units, the height is 4 units, so it's 6 units times 2 units times 4 units. Notice that because of the community property, I can split these out and end up with 6 times 2 times 4, and then I split out the units, and I have units times units times units. It just illustrates why are there units cubed. Okay, it's 48 units cubed. 6 times 2 is 12, times 4 is 48. So that would be the volume of this particular polyhedron geometric shape. Okay, now there's a kind of a general understood formula for most geometric shapes. Except for those that have a point on the top, and I'll talk about those in a minute. The formula for most geometric shapes is the area of the base, which is like right here, this is the base, multiplied by the height. Okay, if you were to find the area of this base down here, which would be 6 times 2 is 12, and then you multiplied it times the height, which is 4, you get 48, just as we did before. Okay, questions? I don't think so. This is pretty easy stuff, really. Okay, when we look at solids, the first thing we really have to do is identify the base. Because if we're going to find the volume of it, we have to know what the base is. And then we have to decide, is it a prism, a cube, or a cylinder? Is it a cone, or is it a pyramid? Is it a sphere? That makes a huge difference, because it makes a difference as far as what we're going to use for a formula to find the volume of that thing. Spheres are totally different. Cones and pyramids, they don't go straight up. They have a slant height to them, so that makes a difference. If it's a prism, cube, or a cylinder, it is the very simple formula of the big B, which means the base, okay, times the height. And height is usually pretty well defined for you. You should be able to find it. If it's a cone or pyramid, then the volume is the big B again times height, but then it's multiplied by 1/3 or divided by 3. And that's because of the point on the top. It takes away from the volume, because if you have a typical cone, okay, it's going to look like this, okay. Well, where's the rest of it? Okay, so we're cutting off this part of it, and therefore this is 1/3 of what would be like a whole piece, so that's where the 1/3 comes from. And pyramids are the same thing. If it's a sphere, it has a different type of volume formula, and this one, you've got to write all these down, but this one's really important because it's a hard one to remember. Volume equals 4/3 pi times r cubed. So whatever you have for r, you would cube that, which means you take, let's say r was 2, you would go 2 times 2 times 2, and then it would be times 4/3, and then if you use 3.14 for pi, You multiply it times that. So that is definitely a little different. Spheres are pretty much unique in that respect. Now, you have seen this sheet before if you've been watching my lessons. And I just kind of want to identify, just take a minute or two to identify some bases for you. Here's a cylinder. This was with lesson 67 actually. Here's a cylinder. Either one of these could be considered the base. You would take the area of this circle, pi r squared, and multiply it times this height right here. Okay. You have a sphere here, and the volume of a sphere is 4/3 pi r cubed, r being right here. Okay. And you would use 3.14 for your pi. You have a cone. It has a point. You have a triangular pyramid. It has a point. So find the area of the base, multiply it pi r squared, multiply it by the height, and then divide it by 3 or take 1/3 of it. Same thing with this triangular pyramid. Find the area of this base, which happens to be a triangle, so it'd be base times height divided by 2. Then multiply it times the height of the pyramid. Then divide it by 3. So that's got like 3 steps to it. Rectangular prism, basic, find the area of the base and multiply it times the height. Okay. Another triangular prism here, and you've got, this is a triangular prism. It is not a pyramid, it's a triangular prism. So here's your base. So pi r squared, or excuse me, sorry, the base times height. So here's your height, here's your base, and then times this height. So you find the area of this part, multiply it times the length of this, which would be the height of this prism. Okay, and then you'd have your volume. These two are pyramids. One's facing to the right, one's facing up. Again, find the area of the base, whatever it is, multiply it times the height. Usually you're going to find the height identified by a line, usually set straight plumb down to the base from the tip up here. So this would be your height. It'd be the same way with this. This would plumb down to here. I say plumb because in construction, for them to find the height of any structure, they oftentimes will drop something that's called a plumb line, and gravity helps it to hang exactly center, so that you know exactly where the center is. But you would find the area of the base, multiply it times this height, and divide it by 3. Area of the base, multiply it times this height, divide it by 3. Okay. Alrighty. Question. I want to just run over a couple of things here. Is it possible for 1 cubic yard to equal 27 cubic feet? And that is actually, I think, one of your challenge questions, or one of your practice set questions. Let's do a conversion to see if that's true. Okay. Let's convert a yard to a foot. Well, 1 yard is 3 feet. So that's pretty easy. We know that, right? If we draw a cube, okay, and we make the cube have a yard by yard base. So here's a yard, here's a yard. 3 times 3 is 9. That's your base, so that's your base. Your formula says volume is equal to big B times height. Okay, well if big B is 9 feet squared, and you multiply it times the height, which is 3 feet, you're going to get 3 times 3, which is 9 feet squared, times 3 feet equals 27 feet. 2 plus 1 is 3. So the answer is yes, of course it is possible, because you're just taking 3 times 3 times 3. Okay, so that's kind of an interesting question. One that I think we always get caught on every year when I teach this. Okay, so what if you have a geometric shape that looks like an L? What do you do with that? Okay, how do you find the volume of that? How do you approach it? Okay, so we have 9 cubes. 9 cubes that make this shape. Each cube has these dimensions: 2 by 2 by 1. 2 times 2 times 1 makes it 4 cubic units. Okay, so if you have 9 cubes, and each cube has 4 cubic units, 9 times 2 times 2 times 1 makes 9 times 4. So the volume of this L is 36 cubic units. So in this case, we just took and broke it up into individual units, found the volume of each of the small units, and then multiplied it by the total number of units. So that wasn't too bad. Okay, challenge problem. And this one is going to like mess with your mind just a little bit, okay? What happens when we cut a rectangular prism diagonally? And secondly, what do you do to find its volume? So to be able to get the credit for this challenge problem, you need to draw a rectangular prism, and I've given you some examples earlier in this lecture. Then you need to show me how you would cut it diagonally into two pieces. What does it look like that way, and how would you find its volume? I hope you had a great day, and we'll talk to you later. If you have any questions, bring them to class.